or actually doing some kind of data analytics, using it for some kind of exploration and plotting nice graphs. We can actually have our own graphs as well. Uh, but the data is not interactive. And the live data may not be able to streamline properly if we just rely on Python. And that's why we are now going to see how we can make use of different cloud-based IoT platforms, as well as some of the cloud-based dashboards to capture the data, process the data, and visualize the data for our customers as well as for specific needs. So cloud platform and cloud-based dashboards are interchangeably used. And many times people get confused between dashboard and a platform. So what we are going to do is we are going to see what is the basic difference between cloud platform and dashboard. Then what we'll do is we'll have a look at one of the dashboards in Power BI, and then we'll see how to connect this dashboard to a platform. And afterwards, if we still have some time, I'll show you one of the online platforms, which is nowadays budding, and many people are actually using, many corporations, at least in the United States, are using. So I'll actually just demonstrate or show it to you how that can be used for your applications. So let us start. Uh, Give me a second. So the cloud platform are modern solutions uh, which we can use for connecting devices. We can actually create some of the applications and connect those applications, use those applications, uh, and also we can actually play with our data live. So it is kind of cloud-based ecosystem where we can have data collection, or perhaps I can start with data generation, data collection, data manipulation, and data visualization, uh, so that we can have a proper understanding of the data for future references. Now, there are multiple cloud-based platforms, and they provide specific services. And one of the services which IoT platforms provide is platform as a service, which means that you can build your own applications and services using their inbuilt features or built-in features. One of the examples is AWS IoT. They have a plethora of different features, so it is just drag and drop and actually trying to just connect everything together. Now, whenever we talk about IoT applications, we have to connect and manage devices using cloud. Now, those IoT devices are located at a remote location, which means we have to create some kind of dashboard. We have to create some kind of platform where we can actually manage that IoT uh, from a remote location. And if there is any problem, if there is any need, we can actually mitigate that remotely. And perhaps actually we can right away manage the applications as well, so that we can have different versions of applications. We can actually control different user access rights. So all that can be done using IoT cloud platform. And there are many IoT cloud platforms nowadays budding. I have listed some of the IoT cloud platforms. Microsoft Azure IoT Hub. The next one is by Amazon, AWS IoT Core. Google is also into cloud business as well as in IoT business. Dell has recently actually stepped into it along with IBM. Rather, IBM Watson is one of the pioneers in IoT cloud platforms. So these are big giants into IoT platforms. Along with that, there are some open source, free to use platforms, and many organizations are using those platforms. One of my favorites is IoT Things Board. Things Board is very easy to use, and they have all the resources available online. So, if time permits, I'm just going to talk about it shortly. Another one which is very similar to ThingsBoard is ThingsWorks, AAIoT, and Freeboard. So, as I mentioned, I'm going to talk a little bit about Microsoft Azure, IoT Hub, and also about ThingsBoard. I've been using Microsoft Azure for some time. We have some wearable devices, and we collect data from wearable devices from different locations. We have uh, obj- uh, two or three subjects from Europe. We have multiple subjects in India as well as in United States, and we get live data from all those subjects using Microsoft Azure technology. Many of my students also use ThingsBoard, and rather in the data visualization course, which I teach at FIU, we use ThingsBoard a lot. ThingsBoard is quite powerful, and if you want to develop any of the labs for IoT, I would recommend using ThingsBoard. And I will actually demonstrate that. I'll just show their website and how we can actually get proper resources for your labs at the end of this session. So coming to Microsoft Azure IoT Hub, one of the reasons why I use and I recommend using Microsoft Azure is because it is owned by Microsoft, readily available, and supports a very large number of devices. So it is very great for scalability. Perhaps actually some of the utility companies in the United States rely on Microsoft for their activities. It's very strong in terms of security. The reliability is about 99.95%. It has very high reliability with 99.9% uptime reliability, which is quite good. Uh, and I myself I'm using Microsoft Azure for almost now 3 years, and I never had any issue with their uptime and any of the other issues such as security and everything. It provides software as service, platform as service, as well as infrastructure as service, uh, and supports different programming language. Rather, uh, in one of the classes, we use Python and we use R programming to do our coding, and then we actually run them on Microsoft Azure. And if any of them is not supported, just write an email to their support team, and they'll be readily working with you to make it available. It supports many different programming languages, tools, and frameworks, including both, and this is the key, Microsoft specific as well as third-party softwares and systems. And the next one which we are going to discuss, as I mentioned earlier, is ThingsBoard. It's a standard all-round open IoT platform supporting most popular communication protocols such as MQTT and everything. Uh, we use it to collect and store data, define algorithms. Uh, we can also set up different rules, and we can actually create a really nice dashboard using ThingsBoard. And once this dashboard is created, we can actually set some triggers for different actions. We can put online reports very easily using ThingsBoard, as well as using Microsoft Azure. Yeah. So now the good thing about ThingsBoard is it's free to use, and it has very strong support, and we can actually use the custom built applications as well as technologies to create different dashboards and those dashboards are live and they are very easy to use. Uh, and we don't require any programming or any technical skill to use their applications. Now, these are all IoT platforms, which I mentioned earlier, IoT Hub and open platforms. Now, there is another concept which is very popular, and it is about IoT dashboard. Now, IoT dashboard is something like your car dashboard. You're driving a car, and in front of you, we have different indicators. We have speedometer, we have tire pressure sensor, we have temperature sensor, we have, say, for example, uh, engine check signs and everything. There are some triggers as well on your dashboard, car dashboard, but it is just a dashboard and it is just giving some kind of information to you about the state of your car. But dashboard is not a car. We require engine, we require different sensors, we require different communication systems so that the data from different sensor, different parts of the car is actually showed onto your dashboard. And based on the information shown on your dashboard, driver will take different decisions and drive the car accordingly. So IoT dashboard is exactly like the car dashboard where different data is visualized and displayed in front of you. Now, there are some tools which actually not just perform data visualization, but they also help to transform our data. So that is plus or added advantage with the dashboard. But even with the data transformation tools, IoT dashboard does not qualify to be the IoT platform. The primary purpose of the IoT dashboard is to provide human readable information to remotely monitor historical and real-time IoT data. And that's the key here, that it provides human readable information so that we can take or monitor the data as well as take some decisions. And okay, and then of course, the dashboard is consolidated and arranged on a single screen so that we can monitor everything in one place. And that is IoT dashboard. So in next slide, I'm just going to compare the IoT platform and IoT dashboard. So IoT platform is both hardware and software system for managing IoT devices and perhaps collecting, storing, visualizing, and analyzing data from those devices. Now, most of the IoT platforms will have their own dashboard to display the data, but some of the platforms are essentially, as I mentioned earlier, are just dashboards. They do not perform any of the actions such as collecting, storing data, as well as analyzing the data. They are just used for displaying the data. And that is the major difference between dashboard and platform. So we can consider IoT dashboard as a subset of IoT platform. And perhaps we can also consider some of the advanced IoT dashboards as a basic IoT platform. So I still have some slides about IoT platform versus IoT dashboard. The dashboards can usually display data and control devices. Platforms can collect the data from various sources, store the data, display data, run the test, and deploy device updates and manage device inventory. Now, this IoT platform and IoT dashboards are gaining popularity in last couple of years. And if we look at the predictions, by 2023, it is expected that the IoT platform and IoT dashboard market is going to reach to about 23 million. 23 billion, not million, billion, which is a very big market. Now, if we couple the IoT platform and IoT dashboard uh, business with sensor business, then cumulatively that is going to be more than about 100 billion in next couple of years. So there is huge demand uh, in IoT platform and IoT dashboard development, perhaps developing some different advanced sensors as well as developing some of the applications. So I highly recommend your students to look into these prospects and actually apply for, or like maybe taking some of the courses in IoT so that they can be easily employable within next couple of years. Now, what I'm going to do is I'm going to start talking about one of the IoT dashboards. We'll see like what are the fundamentals of IoT dashboards, and then we'll see how we can connect IoT dashboard with IoT platform. So let us look at the attributes and advantages of IoT dashboards. One of the attributes is to automatically enhance the incoming data from your IoT device with location, time, weather, temperature, and other external factors unique to your customers. And that's the case. Like we are actually going to collect bunch of data from your sensors, from your IoT data, and we're going to enhance that data so that you can show it to your customer in a unique way. Now, we can use these IoT dashboards so that users and operators can remotely monitor, control specific assets and processes, and depending upon the safety requirements, we can access and control the environment from anywhere in the world. And as I mentioned earlier, we have developed some of the dashboards and platforms where we are actually capturing data from Europe, from Asia, from Americas uh, at the command and control system in my lab. And that is quite possible. And perhaps actually we are using some of the techniques such as smart grid and other technologies, cyber physical things, and trying to secure those things from one command and control system, which is just about 10 by 10, or maybe perhaps actually 100 square foot room. So that is possible by using IoT dashboards. Now, we can also monitor the hardware and software so that we can actually reduce the operating costs, as well as we can actually lower the maintenance cost by preempting the product failures and minimizing the downtime. I mean, smart grid technology is still coming to India, but in the United States, we have smart grid technology, and their downtime is almost to 0 seconds. And that they can do by actually using some kind of predictive data analysis, as well as using different sophisticated IoT dashboards and IoT platforms. Now, we can also use IoT dashboards to learn how customers are using their IoT devices at a granular level and let it guide to your product development. So we can take very valuable data from our customer, and then we can use that for our future developments. Now, with IoT dashboards, we can quickly bring our own IoT analytics products to the market and offer premium dashboards and reporting functionality. And perhaps actually, if time permits today, or maybe I can include that in tutorials, self-learning tutorials, we can create dashboards within a minute or within a couple of minutes, and actually you can just publish it within, again, few seconds, or we can actually publish it in real time, and they start actually doing all the things with full functionality. So if you want to create these IoT dashboards, the very first thing is, like we looked at how we can represent our data, we also have to represent how we can represent or build our IoT dashboard. So whenever we are actually trying to build an IoT dashboard, we have to ask certain questions. The very first question we'll ask is what components should be presented on the dashboard. Many times, if the dashboard is complicated or if it is not user friendly, then our users are going to get afraid. They may not have proper user experience and they may not use it to its full functionality. So we have to be very much careful about using the right components to present on our dashboards. Now, the second question we have to ask is where will my data be received and processed? Perhaps we can actually create some kind of databases and then we can actually take that data from there. Or maybe we can actually just take the real-time data fed to your system, not stored anywhere, and then we process. So we have to actually take that into account as well. And then based on that, we have to also make wise decision on how we can actually design our IoT dashboard. Then the next question is like, if I want to receive my data, then what protocol should I use for receiving data? Or perhaps actually what processes I can use to represent that data. Now, another question which I often actually encourage my students to think about is there any really need of building a custom dashboard? Maybe perhaps what you can do is you can use some of the ready-made solutions available, just tweak them according to your need, and then use it. You may be interested in creating some of the dashboards, but it is your choice. So like you always think like whether I really need to build a new dashboard or maybe perhaps I can use one of the ready-made solutions. Another question is what gateway will I use? And the final question which I always ask is like, why do I even do IoT dashboards? Because if you are going to get one particular one of your sensors, then you may perhaps need not have to use IoT dashboard. So depending upon flow of your data and depending upon your requirement, depending upon your customer's requirement, you have to wisely choose different layouts of your IoT dashboards and different components of your IoT dashboard. So this is a really simple framework for IoT dashboard. We think in two different areas. The first is decision area, where we think about user experience and user interfacing. We also think about from where the data is coming. Then what are my business goals? Or perhaps like what I'm going to achieve or what I'm going to showcase to my users. So we have to take that also into account. Then we have to also think about the technology which I'm going to use. And also we have to look into what are the standards and protocols that we'll be using for making our dashboard. On the technology side, we have to look into device hardware. We have to look into device software. We have to look into different communication protocols. Then we have to make a decision whether we want to actually send that to cloud, or perhaps actually we can actually just send it to fog and then to cloud, or perhaps actually we can do all the processes at the edge and send the filter data to cloud platform. And then we can actually choose some of the cloud specific applications for my dashboard. So this is a typical dashboard framework which every user has to think about. Now, in the IoT architecture, what we have, or like in the IoT dashboard architecture, I should have written dashboard architecture, we have to think about three different levels. One is device level, the other is gateway level, and the third is data systems. And we have to again wisely think about what are my devices, what devices I'm going to connect, what is the gateway I'm going to connect, how reliably and how quickly I'm going to get my data. Is that a real-time data, or is there any other type of data which I'm going to get? What kind of data systems I'm going to use? That also we have to actually think about it. So essentially, our IoT data moves between these three levels via different channels, different transmission channels. So we also have to look for those transmission channels as well. So we have some connection types which we often use for IoT dashboards. One of the first one is device to device communication. Maybe I can just quickly put it over here. We can use device to device so that there is a direct contact between two smart devices or two sensors or two IoT nodes. We can actually go for device to gateway connection. The next one is gateway to data systems, and that data transfer from gateway to data system may happen from gateway to the data cloud. And the next level is between different data systems. So these are the four different types of connections which we have to think about when we think about IoT dashboard. Now we have different types of IoT networks which we also have to think about, and we have to actually just look deep into it so that we can actually make a wise decision to choose whether, like, I'm going to go for a dashboard and convert that into a platform, or perhaps I can actually start with a platform and use the dashboard in that platform. So that will depend upon what type of IoT network you are using. Maybe there will be a nano network with very few IoT devices. We can have NFC, near field communication. We have body area network, such as communication between wearable devices and your cell phone as aggregator. We can use a smaller personal area network or a local area network, which you are aware of. We can go for bigger campus or corporate area networks, and we can also go for some wide area networks. And depending upon these networks and depending upon the communication technologies which we'll be using, we have to choose a proper platform as well as proper dashboard. Now, for making any dashboards, we use three or four different protocols. The first one is MQTT, which you have already learned in the morning session. It is message to telemetry transport. It's a very lightweight protocol, popular for sending simple data flows from sensor to applications. Uh, the other one, which is little complicated, little heavy, is DDS or data distribution service, uh, for actually capturing real-time data. Now, DDS actually is scalable and is high performance for machine-to-machine communication. We can also use AMQP or Advanced Message Queuing Protocol. Now, this protocol is essentially used for application protocol layer for message-oriented middleware environments. And now the next one, which is gaining more popularity in the last couple of years, is Bluetooth. We are all actually aware of Bluetooth. It's a short-range communication technology integrated into most of our smartphones as well as mobile devices. And we can actually take advantage of the Bluetooth technology for communicating your data with dashboards. Now, let us start thinking about how to build a dashboard. So, whenever I'm thinking to build a dashboard, I have to actually structure my solution. So I have to create a structure which will encompass devices which I'm going to use, variables, the dashboards, and alerts. Now, we also have to think about a device, or we have to select a device based on the environment and the requirement you're looking for to complete. Uh, and then once you have selected your device, or once you have finalized your device, then you can also consider your connection protocol. For example, you may choose different communication protocols such as Wi-Fi, LoRa, Bluetooth, as I mentioned earlier, or perhaps just Ethernet. Now, you can also select a component, the component that will be used in dashboard depending upon the data which you need to show and what you need to build a dashboard for. For example, you might be actually interested in showing the status of your sensor, maybe what is the status of your system, maybe to create some alerts, and perhaps actually you can show that data on a map or on a graph with a timestamp. So you have to choose the components of your dashboards and make sure that these components are not actually getting complicated so that there will be less and less user interactions. By selecting dashboard, what we have to do is we have to create more user experience with your machine, with your device, with your connections. Now, I have some very good IoT dashboard examples, which I'm going to show you. The first one is over here, uh, which is built in Tableau. So what we have is a water tanker in one of the cities in California. And what we can see is that it is showing all the essential things needed to maintain that H2O tank or water tank in a given field. So what it is showing is the temperature, humidity, because based on temperature and humidity, there will be some kind of evaporation. Then it is actually showing water level along with some kind of controls such as what is the dew point today, what is the carbon monoxide level, what is the humidity temperature, and what is the condition of a tank which is watering your field tank. Then and then in order to get you some more user experience, then there's some kind of graphics where we can see the actual water level in a visual form. And then we can also show different irrigation systems. For example, the sprinklers are on, water flow is going on. So all these things are presented in this dashboard very wisely and without complicating anything. Now, good dashboard for measuring the pH. So this particular uh, dashboard is actually devised or like actually developed by uh, some of my students where they wanted to measure the water quality. So what it shows is we have a current pH of water. Then perhaps they are showing some kind of historic data using histograms at different times. Then what is the average pH? Then they are also showing what is the current dissolved oxygen, and then again showing the average dissolved oxygen for the entire day. The next dashboard is a smart bus tracking system, which again, perhaps actually this one is developed by some of the other teams, but it is quite nice. It is a smart bus tracking system in San Francisco. And what we are seeing are 4 different buses. We can see what is the bus speed, we can see what is a bus fuel level, and we can also see their geolocation as well. And we can actually create some kind of alerts as well for these 4 different buses. So these are some of the good examples of IoT dashboards where we are not complicating anything, but we are actually providing all the essential things on our dashboard. Now, there are some don'ts for actually creating a dashboard. The very first one is don't neglect to give the context. By merely putting something in front of audience is not going to help. We have we should not actually be choose the wrong kind of visualization. Always choose the correct kind of visualization. Don't use non-optimized visualization. Don't introduce useless variety. Do not show anything on the same view, and do not clutter graphs and dashboards with useless decoration. And the last one, or like the second last one, is do not design graphs and dashboards that are plain. So do not overdo it and do not underdo it. And that is the key in every area. And do not use any offbeat colors, of course, and that is true in any visualization. Now, there are 4 C's of IoT dashboard visualization. The first one is like it should be very clear, so there should be very good clarity. The next one is conciseness, captivation or captivity, and the catalyst. Now, what we mean by catalyst? So your dashboard should prompt for some actions. So by looking at your dashboard, your user has to actually take some actions and like has to get engaged with your visualization. If the user is actually getting engaged with your visualization, with your dashboard, then you are done. I mean, then you are actually, you are actually doing very great work, and maybe perhaps you can actually be enhancing your business or enhancing the value to your customers. Okay, so what we're going to do is now we are going to create one of the dashboards. And when I say we are going to create a dashboard, uh, I want you to actually do some of the things with me. So use one of with the IoT platforms. So let us go to the browser, and I'm going to look for Microsoft Power BI. Now let's click on the first thing, first link, and go to the products and click on Power BI Desktop. Now, Power BI Desktop is always free. You need not have to pay anything for that. As long as like you are not actually publishing anything for your customer, then you can use it for free. So just go and click on Power BI Desktop and download it. And once you download it, I'm just going to cancel it because Power BI is already installed on my machine. So go to Power BI, powerbi.microsoft.com and download Power BI software. Okay. I'm going to actually just go to my desktop and start opening the Power BI. And by that time, I'll actually go through some of the basics of Power BI. The first thing is so what we're going to see now is the overview of Power BI. I'll be a little fast. I don't want to spend much time on it, and I'll directly show how it works. So the Power BI is one of the powerful applications, online applications, where we can connect and visualize any data using the unified scalable platform for self-service and enterprise business intelligence. So we can use it for BI as well as for our own interests. Now, there are three main components of Power BI. The first one is data sources. The next one is Power BI Desktop, which we will be using. The next one is Power BI Service, which is used for collaborations with different teams and which is used for corporate applications. Then we have on-premise data gateway, and we also have Power BI mobile app. So what we're going to look today is the Power BI Desktop. And I hope like you're already downloading Power BI Desktop on your machine. I'm just going to go a little bit slower and I'll show you how we can actually get the data into Power BI, how we can analyze it, how we can visualize it, and how we can publish it in real time. So let us start with getting data. So we can get data from 100 plus data sources on Power BI, which can be on premises as well as on cloud. So it can be on your computer, on your machine, or from cloud. You can connect to 100 plus data sources. You can actually look at the data shape, you can transform that data, you can clean the data for your analysis. There is always a live connectivity to the on-premises and cloud data sources, and you can extend with custom data connectors for any data sources. I'm just going to skip this slide. Now, what we can do with Power BI? We can really use this tool for transforming and cleaning the data. Many a times, the data which we get from IoT is cluttered data, and we have to really look into that data. And the cleaning of the data and transforming that data can be really easily done using different queries in Power BI. We can also use Power BI to analyze the data. So what we can do is we can actually create some kind of models to connect different data sets. For example, I have 5 or 6 different data sets, and there might be some common ID or there might be some kind of relationships. So I can actually analyze that data visually using Power BI. Then what we can also do is we can actually create some kind of expressions in M language, like C language, we have M language. And by using these DAGs, we can actually create some kind of formulas to connect or analyze the data. Then we can, as I mentioned earlier, we can do some kind of modeling as well. So we can actually divide or chop the data as a fact or a data table. We can connect different data sets or different tables using some kind of schemas. Then we can actually connect to tables using a fact table. So all these things we can do visually in Power BI. Now, one of the best things or one of the key things about Power BI is we can create some measures and calculated columns. So measures are like your functions in C. You can create your own functions, you can create your own formulas and use those functions and formulas in your visualization. And that can be done on the fly. Now, we can actually use measures to store the formulas in model. And we can actually just take, or we can actually just use it for different applications in your visualizations. We can also, instead of using measures, we can also use some kind of calculated columns. So perhaps you can actually creating some kind of columns after your, based on your data, and those columns can be stored in a model. We can actually create different formulas to create those columns, and those can be stored, which is very similar to what you have been using or you have been doing it in Excel. And The good thing about columns is it doesn't require aggregator as against the measures, which requires aggregator to collect the data and to properly actually utilize it into the model. Now, another thing what we can do in Power BI is, as I earlier mentioned earlier, is DAX or data analysis and expression. So DAX, also known as data analysis expressions, is a kind of code written in M language to perform operations on the tabular model. It is very similar to expressions used in Excel, but the syntax and the code is little different than Excel, but it is very similar to what we do in Excel. And most widely used functions are calculate functions, or perhaps date, or end of month, end of year. We can use sum, average. We can use some of the functions like related or relatable. So all these kind of functions we can use to transform and analyze your data so that we can do a really good visualization. Now, we can also do really nice visualizations. Other Power BI is used for visualizations. There are some inbuilt visualizations. Those are easy to drag and drop kind of visualizations. Just drag it, put it in your canvas, and then you can have a visualization readily available. And then those visualizations can be interlinked together. And I'm going to show you one of the examples over there. So all the visualizations, as I mentioned, are interconnected. So they are helpful in slicing and dicing as required. And we can also create some kind of custom visualizations. So the very good thing about Power BI is it has inbuilt Python and R libraries. So we can use inbuilt R and Python libraries, and then we can have our own custom visualization. And of course, we can actually create some kind of bookmarks, we can actually create some kind of navigations, and we can actually create some kind of read-throughs. I'm just going to skip this one because I'm going to show it to you live. I'm also going to actually just skip this one, this as well. Yeah. Now, one of the other things is Power BI is, although it is proprietary, they are open to custom visualizations. And those custom visualizations can be purchased many times free of cost from marketplace, which is available inside Power BI. So say, for example, I want to create a bullet chart, which is not available in my Power BI. So just Google, not Google, of course, it is Microsoft, so don't Google it. Just search it in Power BI marketplace, add it to your visualization and use it. Maybe if you think that, like, I want to create some kind of custom visualizations, you can create it and upload it into the marketplace as well. And some of the readily available visuals are also written in D3 visuals. Some of the custom visuals are also written in Python and R. So you can make use of all those tools to visualize your dashboard. And then once you have visualized it, you can publish and collaborate it. So you can publish that on premise, or you can actually just send it to cloud, or perhaps actually you can actually send it to your collaborator for their review. The collaboration activity is not available for free. If you want to collaborate with your collaborator or with your customer, then you have to pay certain fees. But for my students or for your students as well, as long as they can create nice visualizations and connect IoT devices with Power BI, then they are good. Okay, so you need not to purchase or spend any money on Power BI. Okay. Of course, we can actually use Power BI service to send data on premises and on cloud. I'm just going to skip this one. I already mentioned about collaborate. Okay. So what I'm going to do is I'm just going to actually quickly go to the Power BI desktop, and hopefully you have downloaded it and installed it by this time. So I'm just going to actually open my Power BI desktop and show how we can do different tasks. So okay, so if you have installed Power BI, what you can find is there is a blank canvas, and on the blank canvas, uh, there are certain tabs which are very similar to Microsoft Access or Microsoft Excel. The very first thing is uh, we have three different tabs over here. The first one is the report. The second one is the data, which we are going to use. Right now, there is no data. And the third one is model, which we'll be creating. Right now, there is no model because there is no data. So what we're going to do is we're going to get one of the data. Now, the recent data which I worked on with my students is on countries data. So it might be available. So I'll just open it. So just click on get data. Now, you can have plethora of data available, or you can use Excel, CSV files, you can use JSON, you can use Oracle databases, you can use SQL databases. There are a bunch of things which you can use. And I'm very glad to see that they are actually creating more and more databases. For example, Zoho, which is email provider, custom email provider, and they have also added Zoho as well recently. Of course, I mean, and you can see actually Zethro, again, it is in beta. So like whatever is beta, they're actually providing those custom services for customers. So what I'm going to do is I'm just going to a file. I'm just going to import a file, which is maybe a CSV file. I'm just going to click on that, and I'm going to click on connect. And then I'm going to get one of the CSV files, which is countries, for example. I'm just going to get that one. And as soon as I actually open this data set, there is one function called transform data. So I can use this data as it is and do my visualizations, or I can actually transform that data. So click on transform data, and then you will enter into a really new world, and that is Power Query world. So here you can write different queries in M language, or perhaps you can do that visually and transform your data. For example, what I can do is I just want to uh, remove some rows or remove columns. Maybe I can just then click on remove columns, and then I have actually removed one of the columns over here. Maybe actually I can just click on those, remove columns, but it is now very lengthy. So what I'm going to use is I'm just going to click on keep rows. So, or not, what I'm going to do is like choose columns. I'm just going to choose some of the columns. I'm just going to click on ISO 3, display name, continent, and maybe population. Yeah. And maybe I can go for area. And when I click on OK, then I actually got rid of others. And then I can actually just transform them. So whatever I'm doing here is getting logged over here into the right-hand side pane. And if you want to do any transformation onto your data, just go on to that. Then you are actually back to where it was earlier. And then you can perform or re-perform some of the applications. Perhaps actually I can go to here and then I'm back to where I was earlier. So you can actually do that. So you can actually control your steps. There are many things for transformation. For example, you can actually transpose the rows. You can actually apply some kind of statistics. You can actually run some kind of Python scripts. You can run R scripts as well. You can actually extract some of the data. Hmm. And you can perhaps actually do other things as well. For example, add columns, subtract column, format column, and everything can be done in this Power Query. Once it is done, and once you close this one, is prompted is like, do you want to apply changes? Of course, I want to apply some changes. I just want to see how it is. And then we will be back to the main window, and that main window will show all your things. Now, right now, there is nothing over here. But what you can see here is I have different things over here. For example, area, square kilometer, continent, display name, ISO3 population. And that is what actually I chose uh, into my tables. And that may be actually shown over here in this one. So now I can see my table over here. So this is what I have done. So here as well, I can do some kind of transformations. I can apply some kind of new functions, for example, new measures. And I can also look at the data. Right now, my data is like this. Since there is no other data, I don't have any connections, but maybe actually I can get some more data and then we'll see how we have some kind of connections working. So we'll just click on file, CSV file, connect, and then just go for GDP data. I'll again do the same transformations. What I'm going to do is I'm just going to choose some columns. I'm just going to maybe choose world development index for the time being. Okay. If I click on OK, that will be there. I'm just going to close it. And then I can see that there is one more table over here. Now I can actually correlate between countries and country GDP by making some kind of models, and that can be actually translated into visualizations. So what I'll do is like I just open one of the Power BI visualizations which I have already done, but I can quickly show it to you. So what we have done here is we have tried to visualize different countries and their continents and everything. So it is a dashboard which we have created. How we have created dashboard? I'll just go over here and show it to you. Let's go over here, click on something which we want to visualize. I wanted to visualize continent and population, and then I'll get continent and population over here. Perhaps I can actually go for say Python. I can just use Python, and then I can use a Python editor over here and do whatever I can do over here with Python. I'm just going to go back. Close this one as well. I'm going to add one more thing, for example, the bar charts, and I can select area and ISO3, which is country name. And then I can see that like there are different countries which are actually shown over here. If I want to rename it, I can actually just go here and rename it. Instead of ISO3, I can write countries. Maybe perhaps I can do this country. And then I have country over here. So all these things, all these visualizations can be done very easily into a dashboard. I'm just going to close this one because I'm not going to use it. I'm just going to use this one. Now, we have three different widgets onto my dashboard now. One is population by country, the other is population by continent, and the other one is density by country and continent. Now, say for example, I want to slice or I want to actually choose one of these specific data sets. What I can do is I can go to say Africa and choose Africa. So what has happened is automatically the African continent has been highlighted, Then you can see that like here as well, the African countries are highlighted. Nigeria is on the top. We have Ethiopia, we have Egypt over here. If I click on Asia now, it will show Asian countries. Of course, China is on the top, India is on the second rank. And if I don't want to see just specific Asia, I can just deselect that and then you can get everything. Now, say for example, I just want to look at uh, one of the countries. I just click on, say for example, Indonesia. If I click on Indonesia, then it can actually show that like it is part of Asia and some of the population which is contributing to Asia is from Indonesia and Indonesia is highlighted. So all the data is interconnected. Now, this is done automatically in Power BI so that you do not have to write any special programs or any code over there. And we can also create some kind of measures. For example, area is a new measure which has been created. We have some kind of density, which is a new measure which we created. So those measures can be created very easily in Power BI. Now, one of the good thing about Power BI is it can be very well connected. It can be very well connected with the Microsoft Azure technology. And I'm going to actually go through the Microsoft Azure technology very briefly, and then we'll see how to connect the databases, how to visualize the data. So I'm just going to deselect Indonesia now. I'm just going to minimize it. So we will now see how we can use Microsoft Azure Analysis Services for data visualization and data representation. So what is Azure? As I mentioned earlier, Microsoft Azure is a set of cloud services which help in building, testing, and managing applications without the need for developing all the infrastructure associated with developing an app. As I mentioned earlier, it provides software as service, platform as service, and infrastructure as service. And there are almost 600 plus services currently available on Azure services. One of the services which we will be using is IoT platform, but instead of using IoT platform, we can actually do the similar things by actually playing with databases and all, and that is what I have shown over here. So say, for example, if you want to prepare a database, which is a SQL database, just go to Microsoft Azure, go to create and choose data plus storage, create new thing and go to data storage and select a SQL database. Now, once you have selected the SQL database, then you have to prepare database in Azure. So you can select the name of your database. If you want to do some kind of configuration, then you can do that. And once you click on configure required settings over here, then it will take you to the next plane, and over there you can actually prepare your database in Azure. I'm not spending much time onto it because it's pretty straightforward and pretty easy. I'm just going to skip this one. Once you have actually created your database, what you can do is into your Power BI, go to Azure over here and select the database which you have created. Click onto it. Once you click onto it, it will actually ask for server and database which you already created. Take it into Power BI, and once it is into Power BI, you know how to visualize it. Now, many times what happens is like you get some kind of errors in connecting your databases. So what I do most of the times is I just check my IP and make sure that like the external IP is allowed, and I just actually try to mitigate that. If at all it's not possible, I just call Microsoft support team, and they are really good support team. And then I can do all the Power BI stuff, which I have already mentioned earlier. Now, what you can do is, if it is IoT data, you can either refresh it at particular line, or maybe you can actually just refresh it at particular intervals, maybe after 5 seconds or 5 minutes or 5 hours, or maybe at 12 o'clock in the afternoon or 5 o'clock in the evening. You can actually schedule a refresh so that your users can actually get the data in real time at that scheduled refresh rates. We can actually, if the IoT devices are less than 100, I would just recommend to go for refreshing it per second, because it doesn't require much of the data, and you will see the live uh, status of your IoT data. Okay, I'm just going to skip this one. So this is how you can actually make use of your IoT platforms, the proprietary IoT platforms, for visualizing your data. Now, next thing what I'm going to do is I'm going to take you to the another level of uh, data visualization, and I'm going to briefly talk about Things board. And from there, I might be able to show you one of the examples, or I can actually just go through their websites and show how we can use their system. So let me just give me a minute to stop sharing now. Without my others. Okay, I hope now you can see my screen. Okay, there is a comment. Nothing is understand. He is very fast. We are not understanding anything. Okay, fine, perfect. I mean, Dr. Chatterjee ji, it is expected that I'll be just giving kind of overview. But as I mentioned earlier, I'll be sending all my PowerPoint slides to you. These are self-explanatory, and we are also recording this video, so you can actually go through my recordings as well. What I'm trying to do is to compress many of the things which I cover in my course to 2 or 3 classes. So I might be a little fast, and I might be a little, I might rush a bit, but there might be some kind of tutorials which will follow. Those are self-explanatory tutorials, and with those self-explanatory tutorials, you can understand the subject. But right now, what I'm trying to show you is what is a dashboard, how we can create a dashboard, and how we can create or connect that dashboard with some of the IoT platforms. Okay, so one of the other platforms which now I'm going to talk about is Thingsboard. Again, I might be little fast, but what I'll try to do is, like, instead of actually showing the example which Dr. Haran is mentioning, I'm going to actually just take you to the resources, and then it's up to you how we can use those resources. So let us talk about another cloud platform and a dashboard, which is Thingsboard. So let me go over here. Now, Thingsboard, as they claim, is an open source IoT platform. I already mentioned that Thingsboard uh, is a great tool to connect and mitigate some of the activities onto the user level. We can actually manage our devices using Thingsboard, and the Thingsboard has the attribute of scaling. So like it can be scaled at any level. As I mentioned, one of the utility companies in United States is using Thingsboard for their customers, and their customer base is about 5 lakh uh, customers. So we have 5 lakh devices along with some additional resources, and all those are connected to Thingsboard, and uh, that is actually used for uh, managing all those devices. Okay, anyway, it supports most popular communication protocols. One of the protocols which we often use is MQTT, which we have already learned. Uh, as I mentioned, Thingsboard helps to collect and store sensor data, define algorithm to process big amount of data, and set up rules on how the platform should react. We can also set some triggers for actions to happen. And based on those actions, we can actually create some alarms. And perhaps actually we can send some emails, we can create some reports, we can print reports, we can actually send messages to customers, all that can be done in Thingsboard. So if you want to use Thingsboard, it is expected that like you need not have to use any programming language. Even if you don't have any programming experience, even if you don't have any technical knowledge about uh, the Thingsboard system, still you can use it. As long as you know how to connect your IoT device with Thingsboard, then you can actually use it very efficiently. Uh, I'm just going to skip the architecture because it is not required, but maybe I can just show you some of the key components. So with Thingsboard, we can actually connect different devices using HTTP, MQTT, and COAP. If at all we don't have MQTT or HTTP uh, components or connections, we can use a gateway, and then that gateway can actually connect with your uh, databases and everything. And then we can actually use the Thingsboard UI uh, and some of the external systems which can be actually connected together. We can create some kind of rule engines, and those rule engines can actually be used to set some kind of alarms and set some kind of triggers. Okay, I'll just go to the next slide. So all the things which are denoted with this icon are Thingsboard components. Those are scalable components. Then what we have here is let me just highlight this one. We have a laser pointer. Okay, so fine, perfect. So we have the Thingsboard components. So like we have essentially 3 different components here: HTTP, MQTP, and COAP. Then another components are Thingsboard UI, Thingsboard core, and rule engine. Then we have some message queue. The message queues are over here. So these are the message queues. So we can use Kafka, we can use RabbitMQ, or we can use any services from AWS or from Azure to queuing our messages. And then we can also have some kind of databases which are connected to those queues. Okay, so now what I'm going to do is I'm going to take you to the Thingsboard website, and I'm going to show you what are different things over there and how you can use it for your applications. Okay, so I hope like you are able to see it properly. Uh, so this is a very simple website to use. What you have to do is you have to actually go to your account over here and just click on get started. And when you click on get started, then you will be actually taken to a really nice documentation. And I often told my student that, okay, I guess this screen is not shared. Thank you for letting me know. Give me a second. Okay, I hope now you are able to see the screen. Now, the Thingsboard website itself is a self-explanatory website. It is open source, and what you can do is whenever you go to this website, just click on this three buttons, menu buttons, and click on Get Started. Now, getting started has all the resources needed to start with our Thingsboard. Go to Introduction, and afterwards, there is a nice YouTube video available over here. I'm just going to click on it. And
This is
I'm going to stop it over here. Now, this tutorial is a very basic tutorial which they have made, but is kind of uh, the first example I give to my students. So what they are trying to do is to collect and visualize data from two different thermometers. And I'm just going to stop it and again to start over here. So there are two different thermometers, and those two thermometers are sending data to the asset or to the building, and from there we're actually going to collect and analyze that data. So the first thing first, I'm just going to pause it and I'm going to go over here. So whenever you go to Thingsboard, make a login. Once you go to the login, you will be coming to this page over here. Now this page has 4 or 5 different components. Now the first component is a rule management. So you are creating certain rules to connect your data and connect your uh, devices to your system. Then what we have here is customer management. We don't do customer management often because we're not into that segment. The customer management is all about taking input data from customers and everything. We do have asset management. For any project, you have to define your asset, which means you have to have a premises as an asset. For example, you are actually putting your sensor in a building, then define building as your asset. Or perhaps if you define lab as your asset and all these IoT devices are into that lab. So that lab is an asset and your IoT components will become your devices. So you can actually do the device management into the devices. Then once you have devices and assets at place, you can actually go to dashboard management. In the dashboard, there are multiple widgets like what I showed you earlier in Power BI. So those are drag and drop widgets. Just click on those widgets. And once the widgets are up, what you have to do is you have to connect those widgets with your devices. And that is again very straightforward. So after creating those widgets with the devices, you can actually have two or three different layers of dashboards. And that is the next part. So we have a dashboards which are interlinked to each other. And for interlinking dashboards, what you can do is you can use rule chains. I'm just going to go to the next one over here. And I'm just going to show you the rule chain here. Okay. So what is rule chain? A rule chain is a graphical representation of how you are going to model your data. So here we have an input. That input is going to go to a message type switch, any one of these switches. And once we receive message at this point, then we are going to do take some of the actions. One of the actions is, for example, we can use MQTT telemetry to get the data. So you can just click on the telemetry and then you can actually save the data or save the time series data collected from your sensor. So that is what you can do in a rule chain device. So essentially you are doing the same thing what you have done in Power BI. You are trying to get a data, connect the data, model the data, and once the data is modeled, then you are actually going to send it to your dashboard. Now here, what we have done is like we have created a demo dashboard. Now, how we have created a demo dashboard? We have gone to widgets, clicked on one of the widgets. One of the widgets is a digital gauge. We have actually chosen that digital gauge and configured that digital gauge. So how we have configured it? We have actually chosen what is the temperature range. Right now, they have taken temperature range, which is from 0 degrees Celsius to 6 degrees Celsius. And then we have actually starting point from 0, which is right now indicated. And if the temperature goes beyond the set limit, then we can actually trigger alarm. And that alarm triggering can again be done using rule chains. So I'm just going to show you that. Okay. So here, what we're doing is we are actually taking input from our sensor. We are doing some kind of temperature check. And once the temperature check is done, we are going to create one alarm. And that alarm will be actually connected to our input. And now I can just play it over here. Now, another thing what we have to do is many a times the data connection between your IoT device and your widget is not proper. So you have to make sure that you use some of the components such as CURL, or maybe you can use a postpone to use or connect your data with your device or with your widget. I'm just going to run it and you can see. Perfect. So now, right now, you can see that, the temperature is being recorded and we can see the critical temperature as well, which is set at one particular level. And we can see that there is a shoot in temperature. So if there is any shoot in temperature, now what we're going to do is we're going to create an alarm, which will be fed to the next level. And which is being done over here. So we are going to add a rule to create some kind of alarms. So I'm just going to stop it. close it. Okay, so what I recommend you is go to the Thingsboard website, do the video tutorial first, and perhaps like if you have time today, do it today and send me the link of your dashboard by email and mention me that, okay, I mean, we could do it and we didn't have any issue, or like if you have any issue, let me know. Another thing what you can do is you can actually get take help of all the documentation available here. They have actually mentioned it very easily, properly. Uh, they also have some of the lessons. So just go and actually show it to your student and actually use it. Okay. Now, another widget or another dashboard which I'm using nowadays and I'm just exploring it is Freeboard. I'm just going to go and actually show it to you. It is Freeboard. It is one of the dashboards for visualizing the IoT data. And it is very simple. And as they mentioned, it is ridiculously simple dashboard for your devices. And within a minute, you can actually create a visualization without any technical knowledge. Unfortunately, they don't have any support like what we have for Thingsboard. But since it is self-explanatory, you can actually just do it. So just click on start now and maybe just, okay, let me just see if I have signed in earlier. I've been logged in earlier. And maybe I can just go to tutorial and then I can show it to you. I'll just go to test one. I might have created that. Okay, fine. So this is the dashboard which you see when you enter into Freeboard. What you have to do is, again, you have to connect your data source. So go to add data source. Now you can select the data source type, just click on it. I'm just going to click on clock, which is easy. I can just name it as clock one, and we are going to refresh it after every 1 second, and I'm just going to save it. So I have now a data source which is clock. I'm just going to now add a widget. So add a pen. So just click on add a pen. So the pen is over here. Just click on the this one, give a title, widget one, save. Then maybe you can click create the widget type. Now go to widget type. You may want to create some kind of gauge, or maybe you want to create some kind of spark line. So just go and click on gauge, give a title, page one, values, it doesn't matter. You can add a data source. You already have defined data source, which is clock one. Just click on it and go for numeric value and save it. And then you can see that your widget has started working. Of course, now, right now, there is nothing to see over here. Of course, the data is changing because I've just gone for clock, and that clock has taken a value in its numerical format. So as number of seconds are increasing, it is changing. But I just wanted to show you like how easy it is to create a data source, connect to your widget and visualize it. So I highly recommend you to encouraging your students to explore all these free services available, and maybe perhaps you can set some kind of tutorials based around these technologies so that students will learn more. Okay, so if you have any concerns or comments, let me know. If you have any other comments which you don't want to explain it over here now, just send me an email. I'm little lazy in replying to emails, but I will definitely reply to your emails within 2 or 3 days. This is my email. Any comments? Okay,
So
perfect. Look, if you don't have any
if you don't
comments,
have any comment,
I'll
I
see
think
you
we should
again
stop.
on the last day. And till then, take care. Bye bye.
Thank you, sir.
Okay, there is one comment. We have NI resources in our college. Can we use LabVIEW for IoT applications? Definitely, and rather perhaps I'll send you. Please send me an email, and I'll send you some of the resources for uh, the resources which are available on NI website, and they are actually developing IoT lab for our courses. So if I get some more resources, I might be able to send to you as well. Okay. So send me an email. Perfect. Yeah. Okay. So take care and I'll see you on Friday. Bye bye.
Thank you, sir. Thank you. Okay.